Today, welcome to chemistry. Today we're going to be drawing Lewis dot structure rules number 1. Okay, and we're going to be drawing the Lewis dot structure of methane. Before you carry on with this video, I want to make sure that you do two things. You're going to review 2 lessons. Lesson on rules for Lewis dot structures, and the second lesson on exceptions to the Lewis dot structure rules. So, let's carry on with the Lewis dot structure for methane. So the first thing that we need to do is we need to know the formula for methane. So here's the formula for methane. Bam! Right there. So it's CH4. The next thing that we're going to do is we're going to follow the rules from the lesson on Lewis dot structure rules. We're going to follow them in order 1, 2, 3, 4, 5, 6, and 7. So, number 1, we're going to count up the total number of valence electrons. So you're going to have to look at your periodic table, find carbon on your periodic table, and figure out what group is carbon in. Carbon is in group number 4, so that's why there are 4 valence electrons in carbon. And hydrogen is in group number what? 1, so that's why there's 1 valence electron in hydrogen. However, how many hydrogens do you see? I see 4 hydrogens in this formula. I only see 1 carbon in this formula. So therefore, I am going to add up these numbers. So that's 4 plus 1 times 4. And that's going to be a total of 8. So this is a total of 8 electrons. So we're going to make these problems very simple. And how we do that is we're going to divide the total number of electrons by 2. We're always going to divide by 2, not any other number. And that way, this will give us 4 pairs of electrons in this case. We're always going to work with 4 pairs of electrons. I'm hoping that you remember the Lewis dot structure rules, and that is you're going to place those electrons in your, quote, bond blender. And here's my bond blender. I got 4 pairs of electrons in here, and now I'm going to distribute them as is appropriate. And in order to do that, again, I need to follow the rules. So the next set of rules is to figure out which is the least electronegative element, and that is the central element. Okay, now I'm going to put an X marks the spot right in the middle there. That tells me how I'm going to have this general shape pattern here for drawing Lewis dot structures. Now, the least electronegative element is the one that's furthest from fluorine on the periodic table, and then there's a little caveat, an additional rule, and that means that it's never hydrogen. So, I've got carbon, I've got hydrogen, and it can't be hydrogen, so it must be carbon. So carbon is the least electronegative element, but never hydrogen, therefore it goes in the middle. It's right in the middle of the plus sign. Hopefully you see the green plus sign there. Now, the next rule is to place the other elements around the central element. In this case, the central element is carbon, and I have hydrogen. So I'm going to place the hydrogens around the plus sign, just like that right there. Okay? Then the next rule is to place pairs of electron, a pair of electron, between the central element and the outside element. I have 4 pairs of electrons, and I have 1 carbon and 4 hydrogens. So I'm going to place a pair of dots in between each of the carbon hydrogens, just like that. And it's on either side of that green plus sign. So that's a pair of electrons in between the central element and the outside element. Now I've used up all my pairs of electrons, so I don't have to apply the other rules. And the other rules are placing lone pairs of electrons on the outside elements, and then placing lone pairs of electrons on the central element. So the next thing I'm going to do is I'm going to verify the octet rule. The octet rule applies for most elements. And that is, I put an imaginary circle around the carbon. And you can see that there are 8 dots around the carbon. That is 8 electrons, and that is the octet rule for 8. So that is applied, and that's a check mark, plus. Then we're going to verify the duet rule, and the duet rule applies to hydrogen only. And you can see that each of the hydrogens only has a pair of electrons around it, and that is a duet. So we generally don't leave Lewis dot structures with dots with bonding pairs of electrons. So what we do is we replace those dots when they are bonding pairs of electrons with a single line. And here's what our Lewis dot structure should look like at the end. Bam! So this is our Lewis dot structure at the end. So each of those bonding pairs of electrons, which is a single bond, is represented now by a single line. And so I have 4 lines around that carbon, and that is representing 4 pairs of electrons, which is a total of 8 electrons. Each line represents a pair of electrons. So my ending result there is what's in the white square. I hope you enjoyed this lesson. I'll see you next time for the next Lewis dot structure.